Hi, today we are doing the sine rule, the cosine rule, and the area of non-right angled triangles. So if you are learning sine rule and cosine rule, it is assumed that you have basic trigonometric knowledge. But however, let's just go through it really quickly. So we know that basic trigonometry consists of the sine, cos, and tangent, and they can be related by the magic word so, ka, toa. I'll explain about this later, but yeah, I think I'll explain about this using a right angle triangle. So let's say we have a right angle triangle with the right angle over here, and that this little angle here is a theta. The side that is opposite theta is going to be the opposite, and the adjacent side that is adjacent to the theta is going to be adjacent, and this slanted looking side over here that is opposite the right angle triangle is the hypotenuse. So we know that the hypotenuse starts with a H, opposite starts with an O, and adjacent starts with an A. So by understanding this, let us look at the word SOH, which is S-O-H. So S is sine, and every time we have sine, cos, or tangent, we have to put the value of the angle. In this case, it's a theta right behind it, and that O stands for opposite divided by hypotenuse, right? It has to be always divided by. So we always need to look at the second letter divided by the third one. Yeah. So if we are talking about cos, yes, you guessed it right. We have to look at CAH because cos starts with a C. Yeah. So cos theta will equal to A, which is adjacent, over H, which is hypotenuse. And that, you guessed it right, again, tangent, so tangent theta equals to opposite over adjacent. Yep. To further understand this idea, let me just assign values to some of these sort of unknown angles. So for example, let's say this angle has a value of 30 degrees. So we're talking about degrees here, and that the opposite has a value of, let's say, just 1. Yeah. So what is the value of the hypotenuse? Yeah. So in order to do this, we have to look at the magic word, which is SOHCAHTOA, and see which one are we actually thinking of using. Okay, so if we have an angle over here, the side length that is opposite the angle is an O, hypotenuse is the H, and so we can only use SOH, which is sine theta equals to opposite over hypotenuse. So let me just use this equation over here. So sine 30 equals to opposite. Oh, yeah, and opposite has a value. Opposite has a value of 1 over hypotenuse. And so we know that hypotenuse is going to be 1 divided by sine 30. Yep, so because I'm cross multiplying over here. Yep, I'm transposing the hypotenuse up so that I can solve it. So what is the value of 1 divided by sine 30? Let me just quickly look at, let me just quickly use the scientific calculator. So this is a calculator that I am using from calculator.net. So 1 divided by bracket sine 30 is going to give me the value of 2. So I know that hypotenuse has a value of 2. So all solved, we can find that the value of the hypotenuse is actually 2. So the SOHCAHTOA is really useful in situations where a right angle triangle is involved. And I know what you want to say, right? What if it is a non-right angle triangle? So this is when we need to use either the sine rule or the cosine rule. So let us just look at this, explore this further. All right, so let's say I have a non-right angle triangle, and I'll just draw it over here, and that this non-right angle triangle has the angles of A, B, and C. So we always write the angles in uppercase characters, all right? And then the side length that is right opposite this angle A right here will be in lowercase a. And so the side length that is opposite B right here is going to be lowercase b, and you guessed it right, this one will be a C. So if we want to use the sine rule, we can actually use sine A on A equal to sine B on B equal to sine C on C. Although I'm equating them like that, it doesn't mean that we have to use all of them. Yeah, so we just need to use two pairs, if that makes sense. So let me just show you with an example. All right, so let's say I have a non-right angle triangle, and I have an angle here which is 57 degrees, and this angle here is 39 degrees, and I have a side length of 22 over here, and I have to find the length of or the value of x. Yeah, so we know that there are two pairs involved. Okay, so we have this angle and the length at the opposite. Yeah, and then we have this angle and the side length that's opposite. So by arranging them using the sine rule, it will give me sine 39 on x is equivalent to sine 57 on 22. Yeah, because we have to put the pairs together, if that makes sense. Like if I am doing sine 57, it has to be over 22. It cannot be over another side length that's not opposite it. Yeah. So can you see clearly that it's actually sort of like two angles and two side lengths involved over here? Yep. And then in order to solve this, we have to transpose the x so that x becomes the subject of this equation. So what I'm trying to do is, by transposing, I mean by cross multiplying. So that means that 22, which is the denominator here, can become the sort of like the numerator over here. So we have the times 22 up there, and then divided by sine 57 equal to x. So it means that the x is being moved up and this is being moved down. Yep. So in order to solve the value of x, let us use the calculator again. So let me just clear this. So sine 39 times 22 divided by sine 57 will give us 16.5 if I correct this to one decimal place. So that means that x equals to 16.5. Done. So this means that I can now solve this question, and it is done. All right. So, okay, this is how the sine rule is used. So now what if we have another situation? So let me just quickly erase this. Just give me a moment. Okay, so I'm thinking of still using this triangle, but let me tweak the values a little bit. So let me just think. Okay, so if I have these two lengths already, yeah, and that, let me just delete this. Okay, and let's say I have this angle over here, and it is 84. Okay, so if the question says find the value of x, okay, we can't really use the sine rule right now because the sine rule involves, let me just show you again, the sine rule involves two angles and two sides. Does that make sense? However, in this case, we have three sides and one angle. Yep. So what are we going to do? We can now think about the cosine rule. So the cosine rule is really easy. So let me just say I am picking this length over here. So according to the cosine rule, a squared will equal to b squared plus c squared, take 2bc cos a. So can we see a pattern right here? All right, we know that if a is sort of like the subject, okay, we need to have the cos a right here. Okay, it doesn't matter which side is the b or c, you can swap them and it will be fine. Yeah, so that would mean that if I am using a b square, if I'm starting something with a b square will be an a squared plus c squared, take 2ac cos, guess what we need to put here? You are right, it's going to be a b. Is that okay? So, and I think you would have guessed it right now. C squared will be a squared plus b squared, take 2ab cos c. Yeah, so you must be wondering, why do we need to use all the different equations? Technically, we don't have to. It depends on sort of like which angle is given or which angle needs to be found or which angle is involved in the maths problem actually. So in this case, this is the angle, this is the one and only angle. So we can actually start by doing x squared equals to, as I said just now, we can start with either this side or this side, it doesn't matter, okay? So let's say it's 22 squared plus 16.5 squared, take, okay, I'm running out of space here, I'll just put it right there. So 2 times 22 times 16.5 times cos 84. Yeah, so all you have to do is key this into the calculator to find the answer. So let's just do it right now. I'll clear this. And we know that 22 squared plus 16.5 squared minus bracket 2 times 22 times 16.5. Okay, I have just made a small error times. Okay, please forgive my typing speed. I'm not the quickest typer over here. So cos 84. Cos 84, okay, will give me 680.36 if I can remember clearly. So now, is this the answer? No, it's not, because it doesn't look right, right? Like if this is 16.5 and that's 22, this line over here, this length over here, it cannot be 680.36. And that's because this is 680.36 is actually an x squared. It's not an x. So in order to get the value of x, just do it really quickly with my own calculator because it's just taking me forever typing it into the online calculator. So I know that x is 26.1 corrected to 1 decimal place. Yeah. So what I'm trying to do is, by using the cosine rule, I can actually solve problems involving non-right angle triangle that has sort of like 3 sides and 1 angle. Okay, I hope that makes sense. And then finally, we have another one. Okay, So according to the title of today's video, we are, I hope I remember this clearly, that's 22 and that's 16.5. Okay, we need to find the area of a non-right angle triangle. Yeah, and it's really easy. We just need to use area, the formula, area equals to half. Okay, side length times side length, it doesn't matter which one we are using first. So side length times sine 84. So if you can see this in your textbook or anywhere, it looks like area equals to half AB sine C. All right, as long as the length that we are using is right adjacent to the angle, that will be fine. All right, so I'm just doing a shortcut again. So half times 22 times 16.5 times sine 84 is 180.5. Okay, so I hope you understand what we learned just now about sine, cosine, and the area of a non-right angle triangle. If you have any question, please comment below. All right, thank you. Bye-bye.